Hi, everybody. This is the Hungry Math Professor, and thank you for coming to my channel. Today, we're going to be discussing A Mathematician's Apology by G.H. Hardy. And this is a fairly, I think, famous essay, at least in the math community. And it's an interesting essay. I would encourage you to read it. I'm gonna, of course, discuss some things I find interesting about it, but I think it's fairly short, and so it's worth checking out yourself and seeing what you think. It was published in 1940, and then there was a forward added by C.P. Snow in 1967, and I definitely recommend that you check out the forward as well. And I like the forward in particular. I'm going to read a quote from the forward to start out because I think it captures how the essay feels when you read it. So this is C.P. Snow in the forward. That is why a mathematician apology is, if read with the textual attention it deserves, a book of haunting sadness. Yes, it is witty and sharp with intellectual high spirits. Yes, the crystalline clarity and candor are still there. Yes, it is the testament of a creative artist, but it is also, in an understated stoical fashion, a passionate lament for creative powers that used to be and that will never come again. I know nothing like it in the language, partly because most people with the literary gift to express such a lament don't come to feel it. It is very rare for a writer to realize, with the finality of truth, that he is absolutely finished. And I think this quote really does sum up a lot of the subtext that you're going to encounter when you read Hardy's words. And even saying subtext is somehow maybe not quite the right word because it's not very hidden. It feels like very much in your face. Um, to try to explain this, of course, the word apology in the title here is being used in a different sense than we tend to use it now. It's being used to give a defense, right? And Hardy is giving a defense of pure mathematics. You might say math for math's sake, or um, math without any applications, at least immediately in mind. Oftentimes, pure mathematics has applications further down the road, but a pure mathematician is not motivated directly by those applications. And he's giving a defense of that pursuit. And but he mentions early on that in order to give a defense of something like that, it's necessarily going to become a personal defense because Hardy is a pure mathematician himself, and so it's bound. Like a defense of pure mathematics is bound to wind up becoming a defense of his own life, and the essay really does feel like a defense of Hardy's life. And I just wanted to read a quote from the very beginning so you can get a sense for Hardy's tone throughout this entire book. Let me just note that Hardy lived from 1877 to 1947. So this book was published in 1940, so it's towards the end of his life. And throughout the essay, he expresses the fact that he's sort of at the end of his mathematical career. He's no longer able to be creative, is how he expresses it, and he's very much disappointed in this fact. The first paragraph goes as follows. It is a melancholy experience for a professional mathematician to find himself writing about mathematics. The function of a mathematician is to do something, to prove new theorems, to add to mathematics, and not to talk about what he or other mathematicians have done. Statesmen despise publicists, painters despise art critics, and physiologists, physicists, or mathematicians have usually similar feelings. There is no scorn more profound, or on the whole more justifiable, than that of the men who make for the men who explain. Exposition, criticism, appreciation is work for second rate minds. And I wanted to read that because this tone does not go away throughout most of the essay. It's hard not to read this essay and not want to psychoanalyze Hardy and try to understand his psychology. He's putting himself on full display, and so I think it's a very natural thing to do. And Hardy is one of the best, depending on how you define this. I mean, he's one of the best mathematicians who's ever done it. Um, he's in that conversation at least, and so he's not lacking in ability or follow through as far as like what he actually was able to do as a mathematician. But I think one thing that strikes me as you read Hardy's essay is he set up um, a criterion of what it means to be successful or what it means to be like a meaningful mathematician that almost by definition disqualifies almost everyone from achieving anything of value, right? And I think Hardy really does think that he has, as a mathematician, achieved some pretty valuable things. In particular, he points to his collaboration with Littlewood and Ramanujan, and so he's very sort of happy about the work that he's done with those other mathematicians. So I think he thinks that he's done some pretty great mathematics, but he seems to find no solace at this point in his life in that fact. The fact that he can't continue to do mathematics, I can't help but feel like, could he have transitioned into being more of a mentor, taking on more grad students, or, there's other things you can do to still be a meaningful part of the community. But if to you, the only way to be a meaningful part of the community is to, contribute creatively at the highest levels, then, you've kind of counted yourself out. And of course, how we age and when we get older, and, how quickly, physically we would deteriorate or mentally is something that we have no control over. So that's something I can't relate to yet, but I don't want to be too judgmental of that particular aspect. I think everybody ages differently, and so there's some details there that are worth exploring in more detail. But when you read this essay, you can't help but try to analyze a little bit Hardy's psychological disposition, and I can't help but wonder if his sort of just intensity of what he thinks is, worth doing, is somehow eliminating his ability to find something meaningful in his later years of his life. Okay, but let's move past that sort of existential reflection on Hardy. We can come back to that at the end, perhaps. But the more meat of the essay that I really enjoy is he gives a almost like an account of the aesthetic criterion of what makes math beautiful. And I like this in part because I think oftentimes people think of mathematics as utilitarian. It's very useful. And there's nothing wrong with that. That's true. I think mathematics is very useful in science and engineering and all kinds of different areas. It's a very useful language and body of work that can be used to try to describe the world around us and all kinds of different phenomena. But I think Hardy is right in the sense that as a working mathematician, I'm not a mathematician because math is useful. That has nothing to do for me why I like mathematics. And I think what's more closely in line with why I care about mathematics is because it's beautiful to me. And of course, when you start using beautiful, becomes a little bit subjective, and Hardy here is not trying to give like a airtight theory of the aesthetics of mathematics or anything like that. But instead, I think he's trying to give some kind of useful criteria that can be used to try to understand the things that mathematicians find beautiful about mathematics. And I like the idea of trying to share these things with students or anyone who's interested to give them a different perspective on mathematics. When we think of art and literature and music, we think of beautiful things. We think of things that can be enjoyed in a beautiful way as a human. We don't always think of mathematics that way, and I think it's important to think of mathematics that way. So, and again, that's a lot of what Hardy is doing in here. You have to get through the sort of British elitist kind of language and the way he talks about things, but underneath that is a lot of discussion of the beauty of mathematics. Let me read a little portion of how Hardy expresses this. So he says, a mathematician, like a painter or a poet, is a maker of patterns. If his patterns are more permanent than theirs, it is because they are made with ideas. A painter makes patterns with shapes and colors, a poet with words. A painting may embody an idea, but the idea is usually commonplace and unimportant. In poetry, ideas count for a good deal more. But as Hausman insisted, the importance of ideas in poetry is habitually exaggerated. The poverty of the ideas seems hardly to affect the beauty of the verbal pattern. A mathematician, on the other hand, has no material to work with but ideas, and so his patterns are likely to last longer, since ideas wear less with time than words. The mathematician's patterns, like the painter's or the poet's, must be beautiful. Beauty is the first test. There is no permanent place in the world for ugly mathematics. So I think that quote gives you a good taste of uh, Hardy's ability to write well and express himself, but also to basically offend everybody in in the way he tends to express things. And also, I think he just brings very little room for anything less than like the ultimate best. But again, let's focus on. I think this is true in a lot of ways about how mathematicians think about mathematics. Not all mathematicians are going to use the word beautiful in this way, but I think they have some aesthetic standard in mind, whether they acknowledge it or not. Um, and it might differ a little bit from Hardy, but I do think Hardy does a good job of capturing this. And he says there's no permanent place in the world for ugly mathematics. This is important to understand some of what he gets at later. And so in his kind of aesthetic criteria, he puts forward some words that he's going to use to describe important aspects of what makes mathematics more or less beautiful. So he's going to say things like seriousness, permanence, depth, generality, and inevitability. And I will try to give just a little bit of a taste of all these terms by using one of the examples which Hardy uses, which is he goes through the proof that the square root of 2 is an irrational number. And I will post a video on this at some point on my channel sometime recently, where I'll try to discuss even more specifically in the proof where some of these aesthetic criterion are. But I'm going to talk about it out loud here a little bit. And Hardy points to the fact that this what mathematicians find beautiful are not just the statements themselves. The square root of 2 is irrational is a nice fact, but it's the proof, the justification, the argument that shows that this is true, which captures a lot of what we find beautiful. And so I won't be able to go through the argument out loud. Again, I'll post a video where I write some things down on my iPad, but I can still discuss a little bit some of the important aesthetic principles that show up in this idea. And so let me start with seriousness. I think for this problem, what makes this serious is it's not just a fact about the square root of 2. It's, the idea that the square root of 2 shows up in geometry, right? This is important. Pythagorean's theorem says if you have a right triangle with two side lengths of 1, then the hypotenuse is going to be square root of 2. And square roots of primes like that show up in lots of geometric figures, rectangles and squares and triangles and all these kinds of things. So what makes it serious is that it's not just a fact about numbers in isolation, but winds up showing up in geometry and all kinds of other areas of mathematics. And so it gives it some it gives a broader appeal in the mathematics itself, and not just like a sort of random fact about one particular number. But I think inevitability is really important principle to think about here. He goes through a little reflection about how, like, you know, it would have been very nice if all numbers were rational, meaning they can be expressed as fractions, right? And at some point in the history of mathematics, like at least before the Greeks, or definitely, Pythagoreans and things like that, but maybe before that, that was like a natural thing to assume, right? Like that everything can be represented as a fraction or a ratio or something like this. And so that's what you want to be the case, right? But then when you go through the proof that square root of 2 is irrational, meaning that it cannot be written as a fraction, and you follow the argument, there's an inevitability. So no matter how strongly you feel that no, numbers need to be fractions, if you follow the argument, you at some point have to give up your stance. You can't remain, you can, I guess, if you want to, but that's not how mathematics tends to work. You can dig in as strong as you want into a certain position, but as soon as the logic and the proof is clear enough to you, you're going to have to change your mind and take seriously the argument put for you. So this is what happened in the history of mathematics. At one point, maybe we wanted everything to be written as a fraction, but the proof that the square root of 2 is irrational and then its generalizations have shown us that that's just not the case. And so we have to accept it and we've made peace with it. And now the idea that square root of 2 is irrational is not such a, um, it doesn't cause the same kind of reaction that it would have had for, the Pythagoreans or the Greeks and things like that. So there's inevitability to it. If you follow the reasoning, you are going to be forced to change your conclusions based on the argument, and that's something that I think is quite unique to mathematics. I mean, of course, like in science, if you do enough experiments, like people are going to change their mind, and according to the evidence, but it's just not as in mathematics. The arguments in mathematics are even more airtight than they are in science, right? Like experiments eventually will change consensus, but there's always a little bit of room for the theory to kind of just explain experiment that's a little bit inconvenient, or there's just a little bit more room in science for this kind of for not quite fitting the facts that's just not there in mathematics. There's just kind of no room for there's no wiggle room there. You either accept an argument or you don't as soon as you understand it. So that's inevitability. And then he talks about generality. Like if this theorem was just about square root of two, then that would not be very general at all, actually. But it turns out that this result, the argument works to show that the square root of any prime number is irrational, but also the kth root of any prime number is irrational. So there's this one argument that works for the square root of two is works for the kth root of any prime number, and that provides a lot of irrational numbers right off the bat using one argument. And again, the permanence aspect here too is that this has not changed. This fact has not changed since at least before, the Greeks or before that. We still use almost the same argument. Maybe we just updated the language a little bit, but the argument is basically the same. So there's a real permanence to mathematical knowledge, and Hardy really kind of discusses that quite a bit. Then, as we transition past some of this aesthetic criterion, that I think is again really interesting. He talks a lot about how beautiful math is not useful math. He talks about how like real math or the right kind of math is not useful, and I think this kind of it comes across a little bit funny. Also, you have to think about when this was published in because so it was published in 1940, and it's important to note that the atomic bomb was dropped in 1945. So I think it feels a little bit of tone deaf in that sense sometimes. Like, he, because for him, it's not just pure mathematics, but also like theoretical physics. He seems to include in there like quantum mechanics and general relativity. And I think it's hard to argue that at least quantum mechanics was very much involved in the development of the atomic bomb. And so some of the words that he says about the uselessness of math, but even like theoretical physics, seems to be so clearly wrong. And, it only took a couple more years for such a distinct example to show how wrong he was. But just to try to explain why Hardy might be able to say this with some kind of clout is just that he makes such a strong distinction between like what he considers the right kind of mathematics, which almost by definition can't be useful because he wants it to be like this purely theoretical math that, again, I still think that kind of math can be useful and could also be useful for harmful things, maybe longer down the road. And, one example that's particularly relevant to what Hardy did a lot of number theory, and he wouldn't have known that computers would come around eventually, and how much when it comes to like cryptography, just sort of problems that we can prove are difficult to solve, no matter how abstract they are, can be useful for securing information over the internet, for instance, right? And so that has to do with factoring like really large numbers is a problem that we know is difficult to solve, and so we can use that problem to secure information over the internet. And that is, of course, more complicated than just a difficult math problem, but that has something to do with it in cryptography. And so that gives an example of how, some like Hardy would not have necessarily anticipated that kind of use of these abstract problems because he wouldn't have anticipated computers, at least not the kind of computers that we have now. So I think it's wrong to say you really can't say what's going to be or not useful in 100 years, 50 or 100 years, and so we shouldn't try to say that. But I think for Hardy, there was like a very distinct line between this sort of pure, beautiful mathematics that's just somehow purely theoretical and somehow almost defines it out of being useful. But again, these things wind up becoming useful in ways that we can't always anticipate. But there's something else that I really like. Another quote I wanted to mention that Hardy talks about how, sometimes people think of physicists and studying physical reality as somehow more real than mathematics. But Hardy kind of turns this on its head and talks about how like imaginary universes, meaning he's using that to talk about mathematics, are so much more beautiful than the stupidly constructed real one, and most of the finest products of an applied mathematician's fancy must be rejected as soon as they have been created for the brutal but sufficient reason that they do not fit the facts. So he's talking about here how like if you're a physicist or an applied mathematician, you might come up with a really pretty theory, a mathematical theory, a beautiful theory even, but if it doesn't fit the facts of how the real world it doesn't if it doesn't explain how things are in an experiment, then you have to reject it. And Hardy really sees that as like a negative thing. Like if the mathematics is beautiful, then you should study it for that reason and not because it describes the real world or not. And and so there's a lot of that kind of discussion here. He also represents a sort of realist Platonic view of mathematical objects at one point, and he talks about how he really thinks that math objects exist in some sense, though he's not going to try to give any kind of philosophical account or anything like that. And let me just end by discussing the last two paragraphs of the essay. So here's how Hardy wraps it up. I have never done anything useful. No discovery of mine has made or is likely to make, directly or indirectly, for good or ill, the least difference to the amenity of the world. I have helped to train other mathematicians, but mathematicians of the same kind as myself, and their work has been, so far at any rate as I have helped them to it, as useless as my own. Judged by all practical standards, the value of my mathematical life is nil, and outside mathematics, it is trivial anyhow. I have just one chance of escaping a verdict of complete triviality, that I may be judged to have created something worth creating. And that I have created something is undeniable. The question is about its value. The case for my life, then, or for that of anyone else who has been a mathematician in the same sense in which I have been one, is this: that I have added something to knowledge and helped others to add more, and that these somethings have a value which differs in degree only and not in kind from that of the creations of the great mathematicians, or of any of the other artists, great or small, who have left some kind of memorial behind them. I like this. This is great, right? But it's again, it's dripping with this like overly negative tone, but at the same time, like this grandiose tone of like I did something amazing. I contributed in this creative way to the the trajectory of human history, but at the same time, this like super negative characterization of it hand in hand. And I can't help but ask like how much was this a consolation for Hardy at the end of his life? When you read the essay, I'm just not completely convinced that the story he tells in these last two paragraphs really has brought much peace or joy to the end of his life. I think that it's brought joy to the part of his life where he was able to contribute in the way that he did, but I can't help but feel I just don't buy the words at the end as actually being um, like meaningful to him at that point in his life. And I think it's a good reflection to, how do we want to live the end of our lives, and it's hard to predict. And so we have to be humble about that. But, in some sense, meaningful the of life may be, we don't know like what's going to be meaningful at the end. And, for Hardy, being a creative artist was sort of the pinnacle of how he lived his life, and that was not something he was able to do, at least not at the level that he wanted to at the end there. And I think it seems to have created some tension in his ability to enjoy his final years. And so I have no answer for how to live our lives with that in mind, but I think it's worth reflecting on. And in any case, I hope you check out this essay and let me know what you think. I will also link to a longer discussion that I did on a friend's podcast in the comments that you may want to check out. And, like, comment, and subscribe. Let me know what you think. And I hope to see you at another video.